All right, this is Algebra Keystone Lesson 4, Orders of Operations. So a couple things to know about orders of operations when you're doing stuff, especially on a calculator. The calculator will normally do things within order of operations. So if you're putting an entire equation on the calculator, it's going to follow, please excuse my dear Aunt Sally, and it's going to do multiplication and division prior to doing addition and subtraction. Okay? So, other things that you need to know, multiplication involving powers. So remember that when I have x to the m times x to the n, that equals x to the m plus n. When I have a power to a power, I multiply those powers. So if I had something like x to the 4th times x cubed, that follows this rule. So I have x to the 4 plus 3, which is x to the 7th power. Okay. Example number 4, x to the 5th raised to the 2nd power is x to the 5 times 2 power, or x to the 10th power. Okay. Example 5 gets a little bit more complicated, but it's the same idea. 2x to the 4th raised to the 3rd power. Okay, so I have to do this, take this 3 to each of the items inside the parentheses, so the 2 and the x to the 4th. Okay, so this gives me 2 cubed times x to the 4 times 3. So 2 cubed is 8 because 2 times 2 times 2 is 8. And this is x to the 12. So this is 8x to the 12th. When we're dividing involving exponents, x to the m divided by x to the n, as long as they have the same base, remember they have to have the same base, x to the m minus n. Okay, negative exponents, x to the negative m power becomes 1 over x to the mth power. 0 exponents, anything raised to the 0 power is always 1. And power of a quotient, so x over y raised to the m is the same thing as x to the m over y to the m. Okay. A couple of examples. Example 6. I have x to the 3rd over x to the 5th, which is really like saying x to the 3 minus 5, which is x to the negative 2, which is 1 over x squared. Okay. Example 7, 2x over 4x raised to the 2nd power. So I have to distribute the 2 to everything that's inside. So this becomes 2 squared x squared, 4 squared x squared. So that's 4x squared, 16x squared. Okay. I can then simplify that. 4 divided by 16 simplifies to 1 over 4, and then I have x2 minus 2, which is 1/4 times x to the 0 power, which is 1, so my answer is 1/4. Absolute value, every positive integer called the natural numbers, so that's 1, 2, 3, 4, so on and so forth, has an opposite negative number, and together with 0, these numbers make the set of numbers known as integers. Okay? So like -5 and 5, they're opposites of each other. Okay? When they add them together, you get to 0. The sum of an integer and its opposite is always 0. Absolute value is the distance from 0 on the number line regardless of direction. It's also called magnitude. Okay, there's a magnitude difference, so like -5, an absolute value also represents a magnitude or the size of a number. Okay, since distance is always positive, 5 and -5 have the same absolute value, and the absolute value is always positive. Absolute value is always positive. 199% of the time, it is always positive. 199%. It's even more than 100%. Okay. So, for example, 8, I have negative absolute value of -7. Okay. The absolute value is -7. The distance from 0 is 7. So I have negative, and this is 7 inside those. I don't actually need them, but 7. This negative outside the absolute value does not affect what goes on inside. So I still have a negative out in front, so I have -7 as my final answer. Example 9, I have absolute value of -5, comparing with the absolute value of 3. Absolute value of -5 is 5. Absolute value of 3 is 3. 5 is greater than 3. This is correct. Okay. Then I have absolute value of -4 is less than the absolute value of -2. Absolute value of -4 is 4. Absolute value of -2 is 2. This is not correct. Okay. All right, there are a couple exercises below. Go ahead and work on those, and then make sure you do your post test at the end of the lesson.